So change of base formula is something that we use, especially for graphing things, or not graphing, but using our calculator for finding things like bases that other than 10 or e. So like I said, our calculator can handle a common log base 10, and it can handle a natural log base e, but a lot of them can't handle other things. So having this change of base formula is going to help us be able to put different bases, logs of a different base, into our calculator and still find answers. So what we have here is that for any logarithms base a and b and any positive number m, if I have log base b of m, I want to convert it to something else, I can do log base a of m over log base a of b. This means if I had log base 2 of 7, that I can convert it with, say, like a common log. So I would just make sure that this internal part goes up here, and then I just do a log base 10 then of that base of 2. So you always do the base on the bottom. Or like I said, that's just a common log. So if I wanted to find log base 2 of 7, then all I'd have to put in my calculator is log of 7 over log of 2, or natural log of 7 over natural log of 2. It's not going to matter what base I use, just as long as it's that same base, base A. So these are both base 10. These are both base, we're supposed to be both base E. So just make sure you have the same base. Let's gonna get started on this first example. So I'm gonna do this in Desmos. I'm gonna find log base 5 of 8. So log base 5 of 8. So I can do this one of two ways. I convert this into common logs. So I do the internal part here, and then the old base down here. So log of 8 over log of 5. And if I do that, log of 8 divided by log of 5, and I'm going to round this out to 5 decimal places for right now. Now, no particular reason, it's just going to make this a little easier. This is approximately, it's not going to be exactly, but approximately 1.29203. So just as a check to make sure that I did this correctly, remember this is the base. This is a base 5 log. So if I did this correctly, I should take base 5 and raise it to the power of 1.29203. I should get 8, or approximately 8, back. So 5 to the 1.29203, we see is really, really close to 8. So this means that this is, in fact, what log base 5 of 8 is. Alternatively, I could have done this by just using common logs. So I could have used common log, or not common logs, I'm sorry. We already did common logs, natural logs. So natural log of 8 over natural log of 5. So I'm going to clear out this part so we can see these right next to each other. So if I do that, we see that we're getting the exact same answer back. So that's why I'm saying it doesn't really matter which one of these you use. You can use the common logs, or you can use the natural logs. If you were planning on doing a lot of other courses that are going to be math heavy, especially like science courses and some business courses, a lot of times we actually just stick to doing just natural logs all the time. So for you guys, take a minute, like I said, pause this, take a minute, and use either common logs or natural logs to help you figure out what log base 6 of 20 is and log base 2 of 5 is as well. All right, So I'm not going to do like common log and a natural log for each of these. I'm just going to do one each. So for the first one, if I want to convert it, I'm just going to use my common logs. So remember, the log of the base goes on the bottom. So log of 6 is going to be the bottom, and then I do log of 20 at the top. And it doesn't matter if I use this or natural logs. So common log of 20 divided by common log of 6 is going to give us approximately 1.67195. And just to check to make sure that this was correct, I'm going to take my base 6 and raise it to the power of 1.67195 to see if I get almost 20, or approximately 20. I know I'm not going to hit it exactly. $1.67195. And as you see, we get really, really close, 19.999999942. We're really close here. So we checked it. It does work out. The log base 2 of 5. I'm just going to do this one with natural logs for no particular reason. Just because I can. So here, I would do natural log, just make sure it's both are natural logs of the 5, and then divide by the natural log of my old base, which was 2. And we're getting here approximately 2.32193. I'm just rounding, like I said, rounding to 5 decimal places. That should be my answer. And just to check to make sure that I did this correctly, I'm going to take my base 2 and raise it to that power of 2.32193. If I was correct, I should get pretty close to 5. So 2 to the power of 2.32193. So you see we got 5.0000000006603. So we're really close. So yes, this worked out as well.